All right, y'all, here we go. Part two. So, volume of known cross sections, part two. And so this one has to do with, you should have written this down before in the last video, is squares with diagonals in the XY plane. So what does that mean? Okay, so we're still in the same drawing here. Looks like so. Y equals x squared. Y equals x plus 2. So we're still in this area right here. So what is happening is, so you have a square's diagonal. So it looks like this. So this is a square, if you look at it this way. We have the right angles like this. But the diagonal right there sits on this line. And so this top part sticks up on the top, and then the bottom part is on the bottom. And this right here sits on this plane. So that's what the middle is, which is the diagonal of this square. Okay, so we got to find the volume of a slice. That's how we do it. Okay, so let's see. So the volume of a slice, the volume of a square is just side squared. Side times side, length times width, dx. That would be the height. Let's make it three-dimensional. There we go. There's dx. Lovely, lovely, lovely. So what are we going to do? So we know that this is top minus bottom. That's not the side. This is the side and this is the side. So how do I get that? Well, let's go back to our geometry again, shall we? So there is we're taking this top triangle, and this is top minus bottom. This creates a 45, 45, 90 triangle because this right angle here of the square is cut in half. Bam, bam. Okay, so remember when we had our 45, 45, 90 in geometry class, isosceles right triangle, the two legs were x, and then the hypotenuse was always x times radical 2. And so what I'm actually looking for is this and this, because that would give me my two sides, and I would be able to find the volume of the slice. And so if this is x and this is x, that's what I want to find. Well, top minus bottom in this case equals x radical 2. And if I can get x, then I can get these two sides right here. So in this case, top minus bottom equals x radical 2. And so divide by radical 2, bam, and that's what x is. That's what these two legs are, which is the two sides of this triangle, this square, sorry. So this is top minus bottom divided by radical 2, top minus bottom divided by radical 2. You may be asking yourself, Mr. Irish, but I thought we weren't supposed to have radicals in the denominator. Well, just watch what happens. You could simplify it, but you don't really need to, because watch what happens. So the volume of a slice, back to this. The side we have is this, top minus bottom divided by radical 2. So it's top minus bottom divided by radical 2 all squared, because it times itself, length times width, dx. So now I have top minus bottom, which is x plus 2 minus x squared divided by radical 2 squared dx. Bam, and that's the volume of a slice. Looking good. Okay, so volume of all the slices. Well, that's going to be the integral between -1 and 2. The integral accumulates all of the volumes of the entire figure. So that's going to be, you can square the numerator, square the denominator. So that's going to be parentheses x plus 2 minus x squared squared divided by 2 squared, which is 2 dx. Done. There you go. So that's the volume when you have a square with diagonal in the xy plane. Let's do one more, shall we? So we need to find the volume when we have circles with diameter in the xy coordinate plane. Okay, so Same picture. Na 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 na. There you go. So here we're going to have a circle, and the diameter is right here on this plane. So this semicircle is above the plane, and this semicircle on the bottom is below the plane. And you have an infinite amount of those going across. Let's make it 3D, shall we? It looks like a hamburger. Are you hungry? I am. Here we go. So this part right here is the top minus the bottom. And we know that the width is dx. So the volume of a slice is going to be pi r squared, not divided by 2 this time because I want the whole circle, that's the face, times dx, equals pi times the radius. Well, top minus bottom is the diameter, so the radius is half of that. So that's going to be top minus bottom divided by 2 squared dx. Alright, so equals pi times x plus 2 minus x squared divided by 2 squared dx. Alright, so that is the volume of one slice. So now let's do the volume of all the slices between negative 1 and 2. So the volume equals the integral between negative 1 and 2 of pi times x plus 2 minus x squared squared. Yeah, distribute the 2 right here to the numerator and distribute the 2 to the denominator over 4 dx. There you go. So we just done 4 new ones in volume 1 and volume 2. And so what I want you to do right now is I want you to scroll down. We did that. We did equilateral triangles. We did that. We did that. So here's our new problem right here. So you have consider the region in the first quadrant enclosed by y equals cosine of x, y equals sine of x, and the y-axis. Find the volume given by the cross-sections perpendicular to the x-axis made up by A, B, C, D. Okay, so pause the video, write that down in your notes, and try and do all those. Now that you've done, here's section 2. Same principle, but here are the new functions you need to deal with. All right, pause the video, do it up. Boom, here are the answers. Lovely, lovely. So here's the answers to the first part with the sine and cosine. Don't worry about the numbers just yet. I'm looking to see if you got the integrals correct. And then here's the answer to the second one. Any questions, hit me up. Email me with pictures of all of these wonderful works you're doing and your notes. Have a great evening. Miss y'all.